Today we are going to discuss on the eigen function for the angular momentum. Now this relation, it is already known to us, that is j square is equal to jx square, jy square and jz square. So if we know that if any operator is applied in any function, we will be getting a constant value of a function. That is, operator is applied to any function, you will be getting the constant value of that function. So this function will be known as the eigen function, and the constant value which you are getting, that will be the eigenvalue. Let us try to understand it in terms of Schrödinger wave equation. Let us consider Schrödinger wave equation, h cap psi is equal to E psi. Now this is an operator which is very well known, that is Hamiltonian operator, and psi is a wave function. So you are getting E psi. E, it is the eigenvalue of this wave function. So this was what I was explaining here, that is any function, if any operator is applied on a function, you will be getting a constant value and function. So this constant value, it is eigenvalue, and this function, it is eigen function. So in terms of A also you can use it, that is a cap psi is equal to A psi, or a cap psi is equal to A phi. So here it can be psi or phi. So this psi or phi, these are the eigen functions, and A coefficient which we are getting, that will be the eigen value. Now consider a equation, that is A psi is equal to lambda psi, where A is the operator and lambda, you will say it is an eigen value, and psi is eigen function. Now we will be explaining it in terms of possible value for component z for the angular momentum. So it will be expressed as Lz psi is equal to lambda psi. Now Lz, it is having a value, that is h upon 2 pi I d by d phi. So since it is psi, so you will be writing d psi by d phi, that is h upon 2 pi I d psi by d phi. So d psi by d phi, this term you will be taking that side, it will become 2 pi I upon h lambda psi. So we want the value of psi, then it will be in terms of exponential 2 pi I upon h lambda phi. In terms of single value wave function, psi phi will be equal to phi plus 2 pi psi. Now we know the value of phi, so we'll put the value of phi in this equation. So phi is exponential 2 pi I upon h lambda phi. Here also phi plus 2 pi, again the value of psi, that is exponential 2 pi I upon h lambda phi. Now this complete term I will be taking in the denominator. So here I will be writing 1. So this I will be expressing this 2 pi I lambda upon h, 2 pi I lambda upon h, it will be expressed in terms of a constant k. So I'm replacing it in terms of constant. Now exponential term, when it comes in the numerator, you will put sign minus ki, I'm taking common, phi minus phi and minus 2i. So this plus minus phi, it will get cancelled, or you can write it in terms of, now when you solve this, that is exponential ki phi minus exponential ki phi and minus 2 pi I k. So ki phi will get cancelled, and you will be left with minus 2 pi I k, that is equal to 1, or k will be equal to 2 pi I upon h. Now we will be taking it in the form of equation cos theta plus I sin theta. So this is cos k 2 pi theta, I will be writing phi, plus I sin theta is k 2 pi phi is 1. So k will have the value 0 plus minus 1 plus minus 2. Since k is having the value 2 pi upon h lambda, so lambda will be equal to h upon 2 pi k. So value of lambda, that will be equal to the postulate for the angular momentum. Now let us do the commutation relationship. Let us do of Lx Ly. In this, as I have already told you, that will be AB minus BA. So that will be Lx minus Yx. So Lx, you are having the value of Lx, you have are having the value of ly, that is minus I h cut y d by dz minus z d by dy, and ly is z d by dx and x d by dz, and Lz is minus I h cut x d by dy minus y d by dx. This we have already derived, so I will be taking directly. On further solving it, half of this will get cancelled. What I am left with is I square h cut square y d by dx minus x d by dy, or I can write it as minus I square h cut square. This I am writing this side, this I am writing this side. This is just a rearrangement. Now I square, it is having a value of minus 1, so minus 1, this will become plus h cut square. So I am getting h cut square x d by dy minus y d by dx. I square I have taken minus 1, minus 1 square will be plus 1 square. Now h square, if you see, you can write h square, h cut square, it can be written as minus iota h cut plus I h cut. So this rearrangement I am doing here, that is I h cut minus I h cut x d by dy minus y d by dx. Now this whole term which is inside the bracket, that is nothing but I h cut lz. So similarly, when I am taking y and z, here it will be lx. When I am taking z and x, it will be ly. Or if I am taking l square, lx square, y square, z square, so l will be lx, ly, lz and half of that.